Can you guys see me? One here. All right. My apologies. I don't know what just happened there. All right. Well, that's a shame that it happened, that happened right as I was explaining this right here. But nonetheless, let's keep it going. So this line x equals 2, where's the line x equals 2 going to go? It's going right here. It's a vertical line at x equals 2. X equals 3 is a vertical line at 3. X equals 4 is a vertical line at 4. X equals 5 is a vertical line at 5. X equals blah, blah, blah is a vertical line. And then the other way around, not the other way around, but instead of being vertical, it's now horizontal. Y equals 1. Y equals 2. So on and so forth. Y equals 3. Y equals 4. Y equals a number is a horizontal line at that particular number. I don't know why it crashed like that. That's happened to me a couple times. So when I see this says to reflect across the line x equals 2. Let's do it. A is going to flip to here. Again, immediately what I'm imagining is just equidistance, right? The same distance. 2 to the left, well, now it's 2 to the right. So there's A prime. B is 2 to the left up there. Now it's 2 to the right. There's B prime. And boom, there's my figure. C and C prime are the same point. It's not going to move. Y equals -1. Okay, that means we have a line of reflection across that point right there, or that line right there. It's horizontal at -1. So when it reflects, it's going, A and C are both 1 above, so A prime and C prime are both 1 below the line of reflection. And then B is clear up there, 1, 2, 3, 4, 5 up above. So 1, 2, 3, 4, 5 down below. There's B prime. And again, to stress this idea of a rigid motion, I hope in all of these examples, you clearly look at them and you're like, oh, it's the same. It's the same thing, just in a different spot. It's the same thing in a different spot. It is the same thing in a different spot. And when, we're doing everything on a screen, so the words that I'm about to say aren't worth as much. However, it's still true that like some students will sketch something and I'll look at it and I'll go, how is that a reflection? Like those two things don't look the same. Like this one's clearly bigger. And they're like, oh yeah. And I'm like, yeah, what do you mean? Like, when you got it wrong. Like a reflection is so obvious when you got it wrong. We all know what a reflection is. If it doesn't look like a carbon copy, then you did it wrong. I just realized that there were blanks over here for me to write what I just wrote up there because I'm a dummy and forgot that it was over here. Horizontal and vertical. Okay, let's look at 15. And we're basically done. It sucks that got cut off and now this part is like going to be separate in a separate video and that's super irritating, but it is what it is. Let's look at this notation here. What is this saying? It's saying take this pre-image and reflect it to become that image. But then what's the follow-up step? It says reflect this image and create another new image. We're doing 2 reflections. So let's check this out. Reflect across the line x equals 1. So that's this line right here at -1. So when I reflect, it goes to right there. All right? And then it says reflect again, right? So now we're reflecting across the line y equals 0. And which figure am I reflecting? The black one or the blue one? Well, the notation tells all. This says reflect this guy, which is this one, and turn it into this, which I just drew. Now it says reflect this. Well, that's this, right? The prime figure. We're going to reflect the prime figure and make a double prime. So 1, 2, 3 is B prime. So 1, 2, 3 below. A's right there. C's down there. So now we have A double prime, B double prime, C double prime. And, that's why this notation is so nice. Like, it's pretty clear what that notation is trying to tell me to do. Because, again, this is called transformation notation, and it says reflect this object across this line and turn it into this one. Okay, we'll reflect that new object across this line and turn it into something else. That's what that's saying. Nothing special here, just doing it one more time. Let's reflect this object. So, boom. 1, 2, 3. 1, 2, 3. So all of a sudden it's right there. And then we reflect again. So all of a sudden we're like that. Reflection. Easy. Easy. It's a little less easy on a screen. Like, the math is still the same, but, like, it just sucks that you don't have a piece of paper in front of you, right? If you're able to print anything out, if you're able to have graph paper, right, it's a lifesaver. Any Geo people on here want to ask a question? Any Geo people want to bounce anything off of me? I'm going to make an Algebra 2 announcement real quick. Thanks, JV. Rocking that Yahoo emo. All right. Announcement posted. Who's in here for Algebra 2 right now? Anybody still here with me? What up, Slow Towner? Where's Uzi at? Is Uzi in the chat? I'll give it another minute or so since I just made that announcement. Let people try to trickle in here. Ooh, I love this one. Good. Anybody new in here? Who's here for Algebra 2? Slow Towners here. Has anybody else trickled in? Are we ready to go? Yes, sir. All right. You too. Mr. 120320005. Heck of a username. Is that your birthday? December 3rd, 2005. All right. So, take a look at, starting now is the beginning of the Algebra 2 replay. Welcome. Thanks for watching. Those of you tuning in live, what's up? Thanks for watching right now. Let's jump right into it and take a look at these guys here. So what is x plus 3 squared? Actually, what order do I want to do this? Let's just jump straight into a problem, okay? Let's jump straight into a problem. This still, what's up, Uzi? This still looks like the same problems that we've been doing. You want to know why? Because it is. It's still the same. They're still quadratic equations. And I've brought it up each time that what I taught you in the very first lesson still and will always work. Okay? So what was that, right? We're trying to solve, we're trying to factor, right? We're breaking it up into x minus something, x plus something, right? Or something along those lines. And how do we do that? We do b over 2 minus u times b over 2 plus u equals c. Right? Let's just keep it going. Why reinvent the wheel? Okay? So here's a review of that. I feel like the music is just like a little bit in my ears still. All right. So let's keep it going with that. What is b? B is 6. So 6 divided by 2 is 3. So 3 minus u times 3 plus u equals c, which is negative 7. So 9 minus u squared equals negative 7. We're going to move the 7 over. We get 16. And while we're at it, move the u squared to the other side. And we get positive u squared. Take the square root, and we end up with, it's hard to write 4. That's a u over there. Square root of 16 is 4. So what did we do with that number? What's so significant about that number? Well, you do 3 minus 4, and you do 3 plus 4, and we end up with negative 1 and 7. So our two factors are x minus 1 and x plus 7. And our solutions, and I've seen some people forget this when checking the answers, are always the opposite of what we see here, right? X equals 1 and x equals negative 7. Those are our two solutions. So this still works, right? On all of these examples, this is still going to work. All right. So let me actually, to compare and contrast, let's look at, oh no, what did I just do? There we go. So we've got x squared. What's this new problem? If you've got like a scrap sheet of paper, or if you printed these out, you can do it on the back of one of your pieces of paper that you printed out. But I want to do this next problem both ways, right? This other way that we're introducing today and the classic way that I've already taught you. And again, if you prefer the way that I've already taught you, you can keep it up and you can keep using it. But just like we saw in the previous lesson, sometimes taking a square root was just the easier option, right? We solved those problems pretty quickly, right? Without the use of the method that I had taught you, right? And if that makes sense to you and you're like, I could use that, then great. But, you know, I want to give you options, but I want to continue to remind you that what I taught you day one works on every single one of these problems. So I continue to remind you of that, but I'm showing you these alternative methods if you so desire, okay? So what is this alternative method? Let me go back up to the tippy top. Take a look at this pattern here, right? When we have x plus 3 squared, what does that mean? That means x plus 3 times x plus 3. That's what it means to square something times itself. And when you multiply these two things together, you end up with this. And I can show you in my box, right? X and 3, we end up with x squared, 3x, and 9. So x squared, 3x and 3x make 6x, and 9, right? We end up with this. Let's look at it again. We end up with this. Let's do it again. We end up with this. There's a bit of a pattern. There's a bit of a pattern occurring here. Do you see that? What is this pattern? Do you notice a relationship between the b and c values when they are written in standard form? So how are we getting, what's the relationship between these two numbers? What's the relationship between these two numbers? What's the relationship between these two numbers? How do we get from 10 to 25? How do we get from 6 to 9? Can anyone in the chat potentially help me before I spoil it? I don't want to eat too much time here for the sake of the replay, but does anyone see a pattern? What can we do to go from 10 to 25? It's kind of like 2 steps. do this, then this. Does anyone see it? You do this, then you do this. Anyone see the relationship between the two? Give it 30 seconds for the stream delay here. If I take 6, we are dividing. If I take 6 and divide it by 2, what do I get? 3. And then you square 3, you get 9. If I take 10 and divide it by 2, I get 5. And then you square 5, you get 25. If I take negative 8 and divide it by 2, you get negative 4. And when you square negative 4, you get 16. So, do you notice a relationship between them? Yes, there's something that you notice there. So, what's a formula, and I use that word lightly, what's a formula for the C value? B over 2 squared. That's the formula for C. So let's practice that, right? I give you this right here. Let's just generate that pattern. Negative 14 divided by 2 is negative 7. Squared is 49. So we could write this as x squared. So this would be the number. What is our goal here? Why do I care? If I add 49, all of a sudden I can rewrite it like this. There's something really nice about that, okay? So what do we have here? 8 over 2, which equals 4. 4 squared is 16. So if I add 16, I can rewrite it like this. I'm not really solving anything here, right? Some students look at what I'm doing and they're like, what are you doing exactly? I'm just practicing a skill, right? Right? No different than one of you just practicing your free throws for basketball. Why are you shooting free throws? I don't know, to get better at it, right? It's not in the middle of a game, right? It's just practice. We're just practicing this skill of shooting free throws. Well, I'm practicing the skill of completing the square is what it's known as. But why is this so special? Because I can rewrite it like that. That is cool. We like to write stuff like that. That is neat, okay? So, let me show you what I would do. Why is that neat? Okay, why is that neat to do? So my first step is going to be to set it equal to 0. Or sorry, my bad. I take that back. First step is move the constant to the right. So I'm taking x squared minus 14x plus 1 equals 0. And I'm going to subtract the 1. So now I have this. Okay. The next step is add b over 2 squared, which is that skill I was just practicing, okay? So negative 14 divided by 2 is negative 7, and negative 7 squared is 49. So I'm going to add 49 to each side, and I end up with this. Okay, well, what's so great about that? This can now be rewritten like this. That is what's so great about it. And if you remember from just a lesson ago, how do you get rid of this squared? We take the square root. Boom. And I'm done. By creating this squared thing, as I referred to it in the past, right, in the previous lesson, like isolate the squared thing and then take the square root. Isolate the squared thing and then take the square root, right? That was what we practiced on repeat in the previous lesson. Well, I didn't have a squared thing, right? My x's were separated, right? My x's were separated. So I made this squared thing, x minus 7, and I was able to take the square root. So compare that to how did I get the 49? That was my completing the square. That was the skill that I was practicing. B over 2 squared. So B is negative 14 divided by 2 is negative 7. Squared is 49. So let's see how that would go down with my method, my original method that I showed you, however many days ago at this point. So again, it's B over 2 minus U. Kind of interesting how they are related there, right? This B over 2 situation, right? They're super related. We're going to get the same answer. It's just a matter of, do you like this new method? Do you think it makes it easier? Great, use it. Do you like the classic method? Does it make sense to you? Then great, use it. Right? I ain't stressing. So let's see what happens. I get 49 minus u squared equals 1. Subtract the 1 over, I get 48. Move the u squared over, I get u squared. Take the square root, I get the square root of 48. And my two solutions are negative 7 plus root 48 and negative 7 minus root 48. Whoa. Right? Now, do you notice something? This was positive 7 and this was negative 7. We're not done, right? Because remember what I just said. Where did I do it? Up here? I said, remember, your answers are always flipped. Your answers are always flipped. So these get flipped, take the opposite, and it becomes 7 plus or minus root 48. And I now have the same solution, right? When you're not done when you add and subtract u, right? You have to flip the sign. Which is easier, chat? Which did we like better? Did we care? I'll go back down there and compare my work, but I'm just going to x squared plus 8x minus 1. 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 All right, we like both. That's perfectly fine. I like both as well. Of all of, well, let me do another one, and then maybe I'll talk a little bit to expand upon this. So let's complete the square on the right. So I get this stuff on its own, right? I get this stuff on its own. So that way I now can swoop in here and add b over 2 squared, which in this case is 16. 8 divided by 2 is 4. 4 squared is 16. Why do I do that? Because I can write it like this. That is nice. Why is that nice? Because from here, all I have to do is simply take the square root, subtract the 4, and I'm done. compared to 4 minus u times 4 plus u equals -1. 16 minus u squared equals -1. Add the 1 over, you get 17. Move the u squared over. So there's our u value, and you take that and plug it in up here. So we end up with 4 minus root 17 and 4 plus root 17. But these aren't our solutions. We have to flip them, right, to get our actual solution. Boom. So why are we completing the square here as, like, what's so special about these problems that, like, oh, we're introducing the square, or we're introducing completing the square? In my opinion, there's nothing particularly different about them. Like, completing the square is something that you can do every time. But as Lil Nat kind of hinted at, it kind of depends on the problem. So, the second that I introduce, 2x squared minus 9x minus 17 equals 0, and you tried to complete the square on this, well, first off, you'd need to get rid of a. But you'd also have to do that if you used my other method too, right? You'd have to get rid of a. So both problems, you'd introduce a fraction, but it kind of depends on, like, which one. I'm not really going to do this problem out because I'm just like kind of like hypothesizing here. Like, okay, like, is this, doing b over 2 squared on this 9 halves? Like, you both, they both have their taste of fractions, right? And it kind of just depends on, like, which one are you gravitating towards? Like, in the end, I guess they're both gonna work. Let's go back up to our problems up here and just kind of keep it going. I've already shown you that my method of b over 2 minus u so many times at this point, today and in other lessons. I'm just gonna do a few more with completing the square, just so you can see it a few more times and see how things pan out. So let's do this one. So in this one, we've already isolated the constant over on the right, so I'm immediately adding b over 2 squared. -4 divided by 2 is 2. -2 squared is +4. So I instantly add 4. Why am I adding 4? Because it allows me to rewrite it like so. 4 is the special number that allows that, right? That's this pattern, this idea of completing the square. 4 is special. It allows me to rewrite it as x minus 2 squared. And then when I take the square root, I end up with x minus 2 equals plus or minus 13. X equals 2 plus 13. 2 minus 13. This one came out nice. I end up with some whole numbers. Not too shabby. We're still doing the b. So the act of completing the square, the pattern. The pattern of, so why is this, right? Like, this and this are the same thing. This and this are the same thing. This and this are the same thing. So what is so special about this number, 25? Because it's b over 2 squared. That's what we're realizing, right? I look at this, x squared plus 18x equals 175, or I look at this, x squared minus 4x, and I'm like, what is the magic C number that allows me to rewrite it like this? Well, the pattern that we identified was b over 2 squared. So what is b? Negative 4 divided by 2 is negative 2, and negative 2 squared is 4. b over 2 squared. So negative 4 over 2 squared. And again, if you don't believe me, if you're like, oh, how are we jumping from this to this? Like, I don't get it. Well, because that's just the way it works out, right? I'm working under the assumption that we see that now. So x times x is x squared. Negative 2 times x is negative 2x. X times negative 2 is negative 2x. And negative 2 times negative 2 is positive 4. Look, when you add your negative 2's together, you're going to get x squared minus 4x plus 4. Exactly. So that's why I added 4, was because it's that super special number that allows me to jump straight to x minus 2 squared. I can just make that leap without even having to think. So let me start this problem over again here. Get your x's on one side and the constant on the other. So here I need to add the 18x. And I need to add the 175 to the other side. And again, like I'm on a mission to write it as x minus 9 squared. That's when I'm on a mission to x plus 9. Sorry. I'm on a mission to write it as x plus 9 squared. But what's the magic number that I need to add? B over 2 squared. 18 divided by 2 is 9. 9 times squared is 81. So we add 81, and I end up with x squared plus 18x plus 81 equals... what is that? I don't want to mess that up. 175 plus 81 is 256. And the square root of 256, what is that? 14? 16. So negative 9 minus 16 is negative 25. Negative 9 plus 16 is 16. 16 minus 9. Why am I blanking? 7. B over 2 in all of these is nice because B is even, right? So we've put a little bit of a handicap on these problems, right? B over 2 results in 9, not 9 halves or something, right? Or, 15 halves, right? The second you have an odd number, you get into a little bit of a pickle. Okay. So let's just imagine that. So I'm going to move the 3 over, and then I'm going to add b over 2 squared. 49 fourths. So I added 49 fourths to each side, which allows me to write this as x plus 7 halves squared. The second there's an odd number, it's kind of annoying, right? And what does this add to be? 12 fourths plus 49 fourths, 59, 61 fourths. Take the square root. X plus 7 halves equals plus or minus root 61 over 2. I don't know, man. Not exactly pretty. Not exactly pretty. But it's doable. I kind of just pounded through a few examples. Is there I don't really feel like there's much to teach on this, just more so through repetition and seeing it a few times. Is there a hiccup at any point that I've just sort of grazed over that I need to elaborate a little bit more on in these examples? I don't mean to rush us through it, but Slow Towner, Lil Nat, MJ. Just do one more. Do you have a request? Do you wanna a fraction? Do you wanna what do you want? Or do you care? You're fair. Okay. So we'll make up something where it's gonna be odd. So again, how about I do one where A isn't 1? Okay, so A isn't 1, so I need to make it 1. That's something that we can unanimously agree on, no matter what method you're gonna choose, right? Again, like, if you're like, you know what, I've done that U method, so like, I've actually been doing it on all these other problems to like check my answers, then just use that one, right? Like, if that is fine with you, I don't really see a point in adding more to your plate, right? It is a useful skill to complete the square, but like, so is my method that it's not mine, right? But so is this other method that I introduced to you. So it's up to you. But in both methods, we make A equal to 1. So let's do that. I made these all divisible by 2 to make things a little bit easier, but not too easy, and you'll see why that is. So we need to make A 1, right? So that's what I got. All right, perfect. So the next step, sorry, Slow Towner, that I'm going too fast for you. I'm going to slow this down here. Then my next step, what am I doing, is I'm trying to get my x's on one side and the constant on the other, okay? Trying to get my x's on one side and the constant on the other. So why am I doing that? I guess I haven't expressed why I'm doing that. It's because I'm making room, so to speak, for this special y value, right? I'm making room for this special y value, right? 24 is not special. Why am I saying y value? I'm sorry. C value. That was a complete... I misspoke completely. I'm trying to make room for this special C value, okay? Because I'm trying to write it like so, right? I'm trying to write it like so. And 24 doesn't do me any good. So I get it out of the way and say, just go over there for a little bit, all right? Can you get out of the way so I can focus? So now, what am I going to do? I'm going to add b over 2 squared. Well, as Nat requested there, I'm doing 5 over 2 squared. We got our fraction. So we're going to add 5 times 5 is 25, 2 times 2 is 4. We're adding 25 fourths to each side. So negative 24, I'll write it as over 1 plus 25 fourths. Now, what's so special about this? What am I able to do now? I'm able to rewrite this as x plus 5 halves squared. because 5 halves plus 5 halves is 5, and 5 halves times 5 halves is 25 fourths. Again, it's this pattern that we're falling into. I don't know if I said it out loud, or maybe it's just one of these things that I know and I forget to say sometimes, is that the number in parentheses is always half of b, right? 8 divided by 2 is 4. That's why I'm choosing to write x plus 4. Half of 14 is 7. That's why I chose to write x minus 7. It just fits the pattern, right? Half of 4 is 2. And what pattern is this? The one that we started with, right? Half of 6 is 3. Half of 10 is 5. Half of negative 16 is negative 8. So I don't mean to skip around, but I'm just trying to go, yeah, we've been seeing this pattern. So down here, half of 5 is 5 halves. And let's get a common denominator here by multiplying by 4 over 4. So negative 24. Negative 24 times 4 is negative 96. Plus 25 is negative 71. I'm going to pause there and wait for you to tell me that you're okay with the fractions right there before I keep going. All right. So now I didn't even intend for this was not on purpose, but it's going to happen anyway. I'm taking the square root of a negative number on the right. So out pops I. Fun enough. So I root 71 over 2, plus or minus. So I took the square root of a negative number, so out popped an I. I can't actually take the square root of 71, so I'm just going to leave it. But I can take the square root of 4, that's 2. So I've got I root 71 over 2. And then I'm going to subtract 5 halves. And I mean, in literally from this point on, it's the same as last class, right? Take the square root, get x on its own, and solve in whatever way that you can. Whether that's, can you actually add the numbers together? Is it just going to be a messy fraction, right? That's up for, that depends on the problem. But we got the squared thing on one side and everything else on the other, so that way we can come in here, take the square root, and solve. That's the same as last class. The new part here is how do we get from this to this, right? That's what we're trying to achieve. Because at the start of the problem, it's not like I can come in here and just take the square root of the whole thing. That doesn't make any sense, right? I have to have just this one squared thing on one side and everything else on the other. I need a constant on the other side. Thoughts, comments, concerns? No thoughts, no comments, no concerns. We're good. I will say in the classwork, B, that you're not going to get a lot of messy fraction action, and well, that's, and there will not be any imaginary answers on the classwork. That was accidental. Not that we don't know how to imagine, not that we don't know how to handle imaginary numbers, but when I made the classwork, it's just regular numbers. Flow Towner, we're good. MJ, if you're still here, you good? Everybody else who's out there, if we're out there, we're good. And, I don't know, it's probably worth saying, right? We can always check our answers with Desmos. I can't check that one because it was imaginary, but the one before it was this messy answer here. Let's check that one just for grins together if you're still with me here. X squared plus 7x minus 3. And we get these two messy decimals, right? So let me plug in what my answers were. It was negative 7/2 plus square root of 61 divided by 2 and minus square root of 61. And looky here. Boom. Look at that. We're geniuses. Geniuses. We did it. We did it right. Oh, is Uzi still with us? Uzi was here. Uzi, you still out there? Well, that's it. Right? Nothing too crazy. I'm glad you guys showed up. Thanks for watching the replay. If you're still here watching the replay. I didn't mean to do that. Well, I don't need to keep you any longer. Thank you, Lil Nat. Thank you. And you too. Yeah, have a good rest of your day. Who knows? What am I gonna do? I don't know. I feel like I got a whole day ahead of me. It's only 3:30. All right. I'm out. Gonna post these replays and be good. See ya.